Hey, what's up guys, welcome to my YouTube channel. In this tutorial, we'll be discussing about how to handle categorical data in Python. I will be discussing all the concepts about handling categorical data in Python. Yeah, before going further, don't forget to like, subscribe, and turn on notification bell. That will be the first to be notified when I upload new coding videos. Okay, yeah, without further ado, let's go. Categorical data are simply information that will be aggregated into groups. They are not in the numerical format. Okay. And if you have ever tried creating a model, a machine learning model with this your categorical data, you always find out that it always creates an error because machine learning algorithm only accept numbers. That's the language they speak. They only accept numbers. Okay. The method which we are going to be explaining in this video, we are going to be learning about the label encoding method. Okay. First of all, we have to have our data set. We're going to be using a Titanic data set. So I'm going to import for our library, which we are going to be using, import pandas as PD. We're also going to import cPy as SNS. Okay, let me run this now. Then next step that I'm going to do now, I'm going to create a data frame. Okay, I'm going to simply load my Titanic data set for my cPy library, sns.load data set. Okay, Titanic, just simplified version of Titanic data set. Titanic. Okay, when I run this now and I call my data frame, the head of my data frame, and I run this, you can see here all my columns in my data frame. Now see here, this is a numerical column. When it is a numerical column, and when you come to this part, you see a categorical column here, which is sex. The example, you see here male, female, male again, just two categories, male and female. And also when you also check other column here, you can also see here this class, so a categorical column. Who is a categorical column? Your adult male is also a categorical column. Okay, let's handle this our categorical column with our label encoder. The first step we're going to do, first of all, we're going to import label encoder from the scikit library from sklearn.processing. I want to import my label encoder. Okay, let me run this now. That which error that gets. Okay, sorry, this also be a form sklearn. Okay, I've imported it now. Then I'm going to create an instance of it. I'm going to call this label encoder LE, because I'm going to say label encoder. Yes. Then I'm going to transform one of my categorical column. Which column am I going to transform? I'm going to transform it into a numerical column. Okay, this sex column. What this label encoder simply do is that it assigns numbers, unique numbers, to each category in your categorical column. Okay, each unique numbers. Okay, let me see. I want to transform this my sex column to a numerical column. All I have to do, I just have to call my le.bit transform. Then I'm going to call my sex column, and it must always be in a two-dimensional array, because if I place one-dimensional array, I'm going to receive an error. So I'm going to place it in a two-dimensional array. Then I'm going to call my sex column now. When I run this now, you can see here what we have here. We have an array of numbers from 0 to 1, 0, 1, 0, 1, 0, 1. So what this simply means is that what this our label encoder simply do is that it finds the unique value in our sex column. Let me show you what it does. Okay, let me call my sex column now. Import.unique. I'm going to see now. Unique. When I run this, you can see here I have just 2 unique value in my sex column, which is male and female, and 1, so I have just 2 unique value. What it simply do is simply minus 1 from my total unique value that I have. Since I have 3, it's going to be 1, so I'm going to have values ranging from 0 to 1. So that's what it simply does here. Okay. What I'm going to do next now, I'm going to create a new column to store this our transformed values. Okay, I'm going to call this LE label encoded sex. Okay. I'm going to transform it now. I'm going to say LE, as I did before, label encoder.fit transform. Okay, always place it in a 2-dimensional array. Specs. We run this now, and then let me call my data frame again, df, and if everything works, I will see a new column of LE sex. As you can see here, it's my label encoded column of sex. You can see anywhere there is male, anywhere there is male, you have a 1 assigned to it. Anywhere there is female, you have a 0 assigned to it. As you can see here, you have male again, 1 assigned to it. So that's how you label encode categorical column. Let's encode my column. Okay, let's encode. We are going to create a column now. Call this let's encode the class column. Okay, class column. Call this class. And let's call this label encoded class. Differentiate it. Label encoded class. I'm going to set it to label encode.fit transform data frame with dimensional array as usual for my class column. When I run this again, let me call my F again. On this, you can see here my class as always. My class has also been transformed, but here now we now have the value 2, because my class here is there are 3 values in my class. There are 3 unique category in my class, which is the first, second, and third class. So it's going to minus a 1 from the third value, making it just 2 class with values ranging from 0 to 2. Okay, well, the problem with this label encoding is that it assigns ranks to categorical values. For example, when we did our label encoding for this our sex column, we found that my male here got a value of 1, while my female got a numerical value of 0. Numerically, my 1 is greater than 0, meaning my male is greater than female, which isn't true. So that's where the one-hot encoding come into play. I will place a link in the description below, which I explain everything about this one-hot encoding method. Don't forget to check it out. And if you are not subscribed to my channel yet, subscribe, because I will be uploading new videos on a regular basis.